Well, we have another question here. Question 8. It is said that given f of x equal to x open bracket x minus 3 raised to the power of 2, with f prime of 1 equal to f prime of 3 equal to 0, and f of 1 equal to 4. Now, before even I proceed with the question, I want you to notice something. Before I proceed with the sub questions, I want you to notice something in the question here. The fact that f prime of 1 and f prime of 3, they're both equal to 0. This implies that they are the local maximum, local minimum of the function. Okay, so it has they are the turning points of the function. I want to see the turning point of these cubic functions because they're both equal to 0 here. So it can be one can be at x is equal to 1. This can determine the maximum or minimum, or this also may determine the maximum minimum depending of how the function is. Okay, you know, cubic function is of the form, it can be cubic function can be this way, increasing, decreasing, and up like that, or this way. Okay, so this is so if a is positive, and it is like that if a is negative. So it's already, as I can see here, a is positive, okay, because x is positive here and x is positive there also. I'm going to rewrite the function here. In question 8, we have given that f of x equal to x open bracket x minus 3 raised to the power of 2. Okay, over here x is positive and the x is also positive, so the product will be positive. So my graph may look something like this. Immediately I can see, because 1 comes before 3, meaning meaning 1 is somewhere here, and then 3 is also somewhere there. So by 1 here we have a maximum, and then by 3 we have a minimum. So far, even before we continue the questions. Now let's get in the questions. Now number 8.1. 8.1. The question says show that f has a point of inflection at x is equal to 2. Okay. The point of inflection, we need to prove that the point of inflection, it has a point of inflection at x is equal to 2. Now, the point of inflections occurs, it is where the second derivative of the function is equal to 0. Okay, so here we have like f of x is x open bracket x minus 3 to the power of 2. So we can work out the second derivative. In high school, you may not know more rules of solving this type of functions. So what you can do, you can just extend this. Okay, this will be x open brackets open brackets x minus 3 close bracket open bracket x minus 3 close brackets, and then we can work out like x times x times -3, negative times x, that's and that, and then this will be x open brackets x squared minus 3x minus 3x plus 9, and then this will make what, x cubed minus, okay, negative 3x minus 3x makes negative 6x times x, that makes negative 6x squared, and then plus 9, that makes 9x. And just another detail, because I don't see any constant term here, I know it's plus 0. By the way, this simply means the line passes through the origin. Okay, but we're not there, just commenting on the question. You know, sometimes anyway, f of x is equal to that. Now let's now find f prime of x. Okay, this will be according the law, I mean the formula for differentiation. You know, if you have like a x to the n, okay, derivative, this equal to n times a times x to the power of n minus 1, right? Now over here it's going to be 3 times x to the power of 2 minus 1, actually 3 minus 1, okay, 3 times x to the power of 3 minus 1 minus 6, nope, minus 2 times 6 times x to the power of 2 minus 1, okay, plus 1 times 9 times x to the power of 1 minus 1. Here, there is an invisible power of 1 there, okay? So this will be equal to 3x to the power of 2, okay, minus 12x, and then plus 9, x to the power of 0, you know, over here, x to the power of 0 is just 0, and then x to, okay, 1 minus 1, I meant to say 1 minus 1 is 0, and then x to the power of 0 will be 1, and then the solution will be, the first derivative will be this. Now, let's do the second derivative then. This will be 2 times 3 times x to the power of 2 minus 1 minus 12 times x, okay? And then I did this because I follow this law in red here. And then note that the derivative of all constants is just 0. The derivative of any constant is 0. So this will be, okay, I can just move my board this way. Okay, split it like, the second derivative here will be equal to 6x, okay, over here it's 1 minus 1, okay, 6x minus 12. So now we're going to set the second derivative equal to 0, okay, and then if I move the negative 12 over, we have like 6x equal to 12, and this dividing by 6 both sides of the equal sign, and then we have x equal to 2. This is proven. Okay. Excuse me. Now, okay. So you will see that the second derivative of so the point of inflection happen is when x is equal to 2. I can prove it this way. If I draw like I draw a number line here, for instance, okay, and then I place in the my value second derivative 2. I want to check if check that if f of x on the left side of left hand side of 2 is less than 0, and if on the right hand side is more than 0 there. Okay, if on the left hand side is going to be less than 0, negative, in other words, the second derivative, okay, the second derivative, let's check. Okay, on the left of 2, I can pick up any number like 1, for instance. Okay, if you check with me, f of 1, f prime second derivative, okay, of 1 will be like 6 times 1 minus 12, and then this is equal to what? Negative 6, and negative 6 less than 0. True. This is true. And then we can also check for the value like on the right hand side of because I pick up value like values like 1 here, I can take also 3 there. Of 3, this is going to be 6 times 3 minus 12, and then this is equal to 18 minus 12 is 6, so 6 is more than 0, it's positive. This is also true, proven. Okay, the next question is question 8.2, and the question says, sketch the graph of f. Clearly indicates the intercept with the axis and the turning point. Now, remember here already we proved in question 8.1, not even 8.1 before I tackled the questions, the sub-questions. By looking at the questions here, I understand that the function is increasing. So increasing, decreasing, and increasing again. Okay, because the leading coefficient here will be positive. You can see it over here. X cubed here, the leading coefficient, meaning the coefficient of the term with the highest exponent. Okay, is positive. If it is positive, then the function will be increasing, decreasing, and increasing again. And if it's negative, it's going to be decreasing, increasing, decreasing again. In this case, we are here. We are here. Our graph must look like this. And then because it's increasing, decreasing, and increasing, so 1 here will be the maximum because 1 comes before 3. So there's turning points by 1. So the maximum is here. And then by 3, it will have a minimum. Now let's dig into it. Do it over here. Question 8.2. We need to sketch. Okay, sketch. How do you write again? Sketch. It's like that, I guess. Now, f of x, sketch f of x. It is given by x minus 3 to the power of 2. Okay, this function here, y equal to y stands for f of x. So y equal to x open bracket x minus 3 close bracket to the power of 2. This has the x-intercept will be, if we make y equal to 0, okay, to find the x-intercept, we make y equal to 0. Right here, x-int, make y equal to 0. So this will be like 0 equal to x open bracket x minus 3 to the power of 2. So this means that x is equal to 0 or x equal to, let me write like this. X minus 3 equal to 0. Okay, we're going to make like either x equal to 0 or x minus 3 equal to 0. Now here we can work out the value of x. X would be equal to 3. Those are the x int. Now the y int, intercept, y int, y int simply means we're going to make x equal to 0. Now, f of x is given by y equal to x open bracket x minus 3. You know, y int will make x 0. So if I make x 0, this will be equal to just 0. By the way, we say that because it doesn't have a constant part, the y-intercept passes through the origin. The y-intercept is the origin, okay, at 0, 0. The graph passes through the origin. Now, let's draw the graph. I want to draw my graph here. Yeah, actually, my ruler was there already. So I want to draw it somewhere like, draw it like this. That's the horizontal axis, the x-axis. Now let's draw the vertical axis. Okay, I'll draw my vertical axis over here. Okay, we have like y, x. Now, it went through the origin. Okay, this is the y-intercept, the graph, yes, and then the x-intercept, the 0, and the x-intercept is also there, and then 3. Let's say this is 1, this is 2, and this will be 3. So 3 is there. Right, now it has maximum at 1 and then minimum also at 3 there. So 1 is where the graph has a maximum. So meaning we're going to sub 1 into the main function here to see the corresponding y value. So if I sub 1 for x, if I sub 1 there, you see that 1 minus, this is the power of 2. Okay, 1 minus 3 is 2, negative 2, negative 2 to the power of 2, positive 4, and then 1 times positive 4, it's 4. So here we have like, let's say 4. Excuse me, let's 4 is there. And then the point of contact is over here. Now, there, if x equal to 3 for the minimum, there, if I have 3 there for x, it's just going to be 0, okay? Because 3 minus 3 is 0, so the minimum lies on the x-axis, okay? And then this will be something like the turning point is like here. Turning points are there also. So the graph, okay, I'm trying to make a curve. Et voilà. So that's f of x equal to x open bracket x minus 3 to the power of 2. Okay, and then I prefer to I can just move it. Oops, it's coming together with the arm. I don't want. Yeah, I can write it here underneath f of x. Good. Now the following question must be question 8.3, and then what does it say? Question 8.3 here, it says for which value of x will y equal to negative f of x be concave down? Okay, remember that negative f of x is a reflection. Okay, now I was saying that negative f of x is the reflection of the function f towards the x-axis. So remember earlier we did prove that where was it? It was here. Yes, in question 8.1. I just give a proof here when we're talking about the point of inflection. So this determines the concavity of the function. So if the point of inflection is here, it will concave up where in this interval when if x is more than 2. This is the original function, and concave down when f of when the second derivative is lesser than 0. Lesser than, it's concave when it's lesser than 2. Here the x value will be lesser than 2, and you want concave half if the x value will be more than 2. So here we will say that x is greater than 2. But now, if you look here, the question says y equal to negative f of x. So it reversed this order. So here, normally it was concave, it's concave up if x is greater than 2. Okay, x is greater than 2. Now, if you times by negative, then it will reverse the order. It will be if x is lesser than 2. So this will be over here on the right, question 8.4. 8.4 on the right. Okay, let's first write f of x concave up if x is greater than 2, and then we'll concave down No, I don't need to say concave down. You didn't ask me that. Now, negative f of x then. Okay, negative f of x. That's actually this will concave up if x is lesser than 2. So this is the answer. The following question would be question that was 8.3 actually. 8.3. Now we're going to do question 8.4. We have like 8.4.1 and 8.4.2. It said, use your graph to answer the following questions. Determine the coordinates of the local maximum of f of x equal to, of h of x equal to f of x minus 2 plus 3. Okay. Note that this function here is a transformation of the initial f of x. Okay, the minus 2 here simply means the function is shifted 2 units to the right. Careful here, minus 2 means shifted 2 units to the right, and then positive 3 here is shifted 3 units upwards. Now initially the function was like this. Okay, f of x, that f of x at 1 here shifted 2 units to the right, meaning the local maximum will be at 3. Okay, the maximum 3, and then 3 units up, because there it was 4, you add 3 there again. Let me write it here so we can visualize it well. 8.4.1, we need to, h of x is given by f of x minus 2 plus 3. So this means we shifted 2 units to the right, so the maximum was the point the maximum was the point 1,4. Okay, so let me write it over here. It's a 0.14. So 2 units to the right means I'm going to plus 2 here by 1, and then 3 units upward, I'm going to plus 3 there. So the new maximum, local maximum, will be the 0.37. Okay, and then question 8.4.2. Let's see. Um, 8.4.2, the question says that Clear claims that f prime of 2 equal 1. Do you agree with Claire? Justify your answer. Okay, Claire, let's see. F prime of 2 equal to 1. She said so. We did find f prime of the function here. F prime of x equal to 3x squared minus 12x plus 9. Okay, now we're going to substitute the value of 2 wherever we see x there. So let's see. I can use a calculator for that. So if I write here like 3, okay, open bracket, 2 to the power of 2, okay. Now minus 12, open bracket, 2, close bracket, plus, oops, I'll say minus, yes, 12, open bracket, 2, close bracket, and then plus 9. This is equal to negative 3. Therefore, Claire is not right, because she said f prime of 2 will be 1, but it is proven that f prime of 2 is negative 3. So I'll say here f prime of x is given by, we define 3x squared minus 12x plus 9. So f prime of 2 will be, I'll sub in the 2 there, 2 there, 2 there also. And then this is equal to 3, and then 3 is not equal to 1. So Claire is wrong. Thank you.